Okay. Oh, I don't want that camera on. Go by camera. Okay. So we are talking about piecewise functions again. A function is defined by two or more equations over a specific domain. Okay. And to define a piecewise function, treat each function like its own graph and write the equation. Okay. That represents that piece of the graph. Next to each piece, write the domain that the function applies to. Did you guys notice that the typing on this is different than what we've seen in the past of our notes? So we are actually working out of your trig book. So this is out of the trig book versus the algebra 2 book. It's left out of the algebra 2 book. All right, but this is something that's very important for us to go to next year, and it fits better in with this part. So that's why we're plopping it in here, okay? So for a couple of days, we'll actually be out of the HMH textbook, probably for the next week, and then we'll be doing it's trig book is your good reference, and then we'll be doing some delta math and some WebAssign assignments to get you guys into those a little bit. All right, evaluate the function for each indicated value. So all you have to do is plug in, but you have to understand which branch it goes into. So you have to make sure the domain is true. So this one right here is any x value that's less than 0. We would plug into the top equation. For this one here, we want any x value that is greater than or equal to 0. So it includes 0, gets plugged into the bottom branch. So I notice that the first one says I have to plug in -2. I know -2 is less than 0, so it goes into the top branch. So I'm going to use this good notation. So this is just you telling me I'm plugging 2 into the function. And then I'm going to go ahead and plug the 2 in. So -2 squared plus 1. And I chose the top branch because that's where it fit the domain. So -2 squared is 4. 4 plus 1 is 5. Okay, this says that we're plugging 0 in this time. Well, I know that the bottom branch, the domain says that it's greater than or equal to 0. So I'm going to use the bottom branch to plug into, and I'm just going to go ahead and plug in. I'm not going to write it out. So I'm going to go 0 in for the x, -1, which 0 minus 1 is -1. The hard part is the concept of which branch do you plug into. Every single person sitting here can plug into an equation and get it right. I know that. I have confidence and faith in that. Even though I've never met you in person, I know you all could do that. Okay? You wouldn't have made it this far if you couldn't do that. Okay? All right. Then we're going to go ahead and plug in the 4. Let me use a totally different color. So 4, it's not less than 0. It's greater than or equal to 0. So I'm going to use the bottom branch again. So we're going to have f of 4 equals 4 minus 1, which equals 3. Okay, so here's what I want you to do. I am going to be quiet for a full minute. I can do that, okay? Believe it or not, in my other world, I'm an introvert, okay? In my school world, not so much, but in my other world, I'm an introvert. All right. So I want you all to try example 2, A, B, and C. Okay, so take a minute, 1 full minute on your own, try A, B, and C. Okay, so here's what we're going to do. We're going to try something a little bit different. I just came up with this idea. Okay, so I want to check where you are in the chat. So in the chat, when you type it in, you need to tell me if you're doing, you need to type g of 3 equals whatever the answer is. G of 1 equals whatever the answer is. G of -6 equals whatever the answer is. But you're only going to do one. You got to do the one you're assigned. So if your first name starts with A or B, the letter A or B, we got a lot of A's in this class. You're going to do A. If your first name starts with C to L, you're going to do B, and if your first name starts with M to Z, you're going to do C. So everybody right now, everybody's responsible for something, okay? Everybody put the one you are assigned in the chat for me, please. Show me you are paying attention right now. You need to actually tell me the answer. There we go, just like Brendan did, okay? All right. Let's see if I have I'm getting a little bit of everything. Excellent. This is good. I like it. I like what I am seeing. Okay, so let's check it to make sure that you're right, because we want to make sure we have agreement on our answers. So it looks like G of 3, I'm seeing a lot of 32s. So let's check out 32. So for G of 3, I would have had to go into the bottom branch, which means I'm plugging in to this part of the equation. So I'm going to say I'm going to put in a cubed plus 5. So 3 cubed is 27 plus 5 is in fact 32. So I think we all agree that G of 3 is 32. All right, G of 1, it looks like a lot of people have gotten 6. So let's check to make sure that that's correct. So G of 1, I would have to go again into the bottom branch because it's equal to. So we've got 1 cubed plus 5, which gets me 1 plus 5, which is 6. That's what you guys are getting. Excellent work, you guys. I'm really impressed. All right, now we're going to plug in G of -6, and I'm seeing a lot of 22s, just regular 22s. Yes. Oh, I've got a -22 somewhere too. Okay, so we've got 22 or -22. So let's see what we got to find. -6 would go into this top branch here because it's less than 1. So we're going to plug in 3 times -6 minus 4. So 3 times -6 is -18 minus 4 would be -22. So make sure you didn't lose your sign on it, okay? All right. Or is the negative sign? Oh, the negative sign is so tiny I can't see it far away because my screen that I'm seeing, no one said 22. Everybody said -22. It's my eyes. That's the problem. I can't see the little dot. It looks like a little tiny dot and I can't see it that far away, even with my glasses on. So the upside is I don't have like the old person issue where I can't read anything up close. All right. I apparently am not that old yet. My husband is, but not me. Okay. So the eye doctor said last week said I was good. All right, we are going to look at example 3. So the difference in example 3 is that we now have 3 branches. It really works no differently, okay? So you follow what's the middle domain is we have to go all the way from -3 to 5. So if it falls in that branch, we would use that equation. So I'm going to plug in the -4. -4 would go into this branch. The only thing I have for -4 is a 3. That's a horizontal line, right? Y equals 3 is a horizontal line of 3. So all I get is the 3 on that one. There's no other work to do. 5 would be in this middle branch because it goes to less than or equal to 5. So I've got 2 times 5 minus 1. 2 times 5 is 10, minus 1 is 9. All right, and then 10 looks like it's going to go into the third branch, and it won't always go in order like that, okay? So you have to really make sure you read through what it's actually asking you. In fact, I will purposely take it out of order just to catch you not doing it right. So I'm going to put that one into here. I get 10 squared, and that gives me 100. Okay. I'm going to pause for just a second to see if to make sure you all have it written down right. Okay. The next one is just a different way of looking at the exact same thing. Okay. So what's happening here, my screen just flipped out. Okay, so what's happening here is instead of giving it to us as f of -4, f of 5, they just put the values in the table. So really what they're asking for in this part of the table is h of 1, okay? They're in this one, they're asking for h of 2, and so on and so on. So I'm going to use those the correct branches, okay? I'm going to show a little bit of work here. So for h of 1, I am less than 3, so I would use the top equation. So 9 minus 1 squared. 9 minus 1 is 8. So I would put 8 in the first part of the table. And then we're going to have h of 2 is next. And again, that's still less than 3. So I've got 9 minus 2 squared. So 9 minus 4, which is 5. Okay. Oh, I should have put my 5 in the table. All right, let's look at the next branch. Here's the next equation. So it's the next number is 3. So we're going to find h of 3. H of 3, I notice, is greater than or equal to 3. So it's going to go into the bottom equation. So we've got 3 minus 3, which is 0. Next, we're going to do h of 4. So 4 is greater than or equal to 3, so it goes in the bottom branch. So I do 4 minus 3, which is 1. And then h of 5, again, it would go into the bottom branch. So I've got 5 minus 3, which is 2. I'm not sure you'll get any in that context, but it's always good, even if we only see it in the notes, to start seeing it represented in different ways, okay? So you will see me do that once in a while, because you're going to see when it's a part of the training program for next year, right? I try to show you in many multiple different rates, because you're going to end up seeing it for in next year's class, okay? All right. These are some things you should be familiar with from Algebra 1. If you're not super familiar with quadratics, we're going to get there, okay? We will do it again. That's kind of, I think we're doing absolute value next and then quadratics after that. So we will get there. You will definitely see these. So we're going to do the best we can today. I don't think I assigned a lot of quadratics. I think I mostly assigned linear stuff in the homework. So you want to recall that the equation of a line is y equals mx plus b, where m is the slope and b is the y-intercept. Hopefully you know that, because we're going to have to actually write some equations of piecewise functions. And then a quadratic function, and this should start looking a little bit familiar. We've been working with this hk stuff, is y equals x minus h squared plus k, where h and k is the vertex. So basically I want you to write it with the vertex. We're not going to mess with the weird a value out front. We're just, can you find the vertex of this parabola? Okay, so I am going to try to write the equation of a piecewise function. I am looking at example 5. Okay, I don't see apparently I've changed example 5 over the years. That's what my example 5 looks like. All right, so I am noticing that the vertex, I'm going to zoom a little bit, see if I can get it bigger. Let me stretch it. It's not letting me stretch it today. There we go. Ooh, there. Oh, wow, look at how big it is now. Okay, that should be a little bit better, hopefully. So I am noticing my vertex point on here. So it looks like I've got a curve and a line. So my vertex point is this value right there. Okay, so I know that I have to do an equation of a parabola for this part and an equation of a line for that part. So I'm going to start by just giving my function a name. I'm going to call it f of x. You can call it whatever you want. Okay, we typically see f, g, h, k sometimes. All right, and then I have two branches of the function, just like we saw, so I'm going to kind of set up for that. And we're going to use our inequality notation that we learned like a week ago. I know that my breaking x value, where it breaks from one function into the other, is at 0. So I know that they have to have a relationship with 0. I know that one of them is less than 0 and one of them is greater than 0. At this point, they are both equal to 0 in the same place. So you can go ahead and choose whichever one you want to have the equal sign on it. Now, it is a delta math assignment where you have to do this. They might be pickier than that, so you might have to watch their little video, okay? All right, so we're going to go ahead and write the equation of this parabola right here. So it definitely looks upside down, so I know it's going to be negative, okay? And I'm going to figure out my vertex point. So my vertex point looks like we are out 0, up 1. So if I am putting that into my equation in my parabola, I don't have any h value, so I don't even really need my parentheses. I could drop that, and I could just write x squared, and then I know for the k value I have to go up 1. So that's the equation of my parabola. All right, we're going to do the equation of our line. I know I've got to have an x, right? It's slope times x plus something. I'm going to start with my y-intercept. My y-intercept happens to be that vertex point. So I'm going to go, my y-intercept is 1, and then I'm going to use a slope triangle to count my slope. I'm going to try to find a good spot on here that I can read. It looks like the slope triangle is right there. So it looks like up 1 over 2 would be my equation of my line. And it looks funny because it doesn't look like y equals, but your y equals is hanging out here, right? Okay, let's take a look at example 5 or example 6. Again, the first thing I'm going to do, I can zoom in more. Is that better? Maybe that'll be better. It's a little bit bigger. I think my pen might get a little fuzzier. So I definitely looking the breaking point looks like it's right there. So that's at the value of x equals 2. Okay, so I'm going to set up my function. I happen to like f of x, so that's the one I use the most. Okay. And I know that I'm going to set up I tend to set up my domain first. So I know it's going to have something to do, I know it's x and something to do with 2. I know if I'm going this way, I am less than 2. And if I'm going this way, I'm greater than 2. And notice, look, my little arrowheads, they made the alligator mouth pointing the correct direction. It doesn't matter. Pick one that's equal to. This time I'm going to pick the top one, but it really doesn't truly matter. All right, the top function definitely looks like a parabola. This time it's right side up. My vertex is out 0, up 1 again. So again, when I fill in this equation, this x minus h squared plus k, notice I put a 0 in there. So I'm not going to put that in my final answer. I'm just going to say x squared plus 1 because the 0 goes away. All right, now we've got to do the equation of the line. So that's my line. I know that I have x plus something, or maybe minus something. I don't know, maybe I shouldn't write it so quickly. I need to figure out what I am counting here. So I'm going to have to know the slope anyways. I might as well figure out what my slope is. So it looks like I'm up 2 and over 1. And then I'm going to start counting that down until I hit the y-intercept. So down 2 over 1, down 2 over 1. What do you know? I hit that y-intercept right there. So it would be plus 1 would be my y-intercept. Okay, example 7 has more craziness, doesn't it? So let's see if you're paying attention. So every time we see a distinct function, we write a new branch. So the last 2 examples had 2 branches. So can anybody in the chat, everybody tell me, how many branches of this function in example 7 are we going to have? So how many equations should I be writing? I have one person who, there we go. All right, I'm seeing 3s and 4s, and I saw a 2. Okay, so we got to figure out how many equations that we have there. Okay, so I'm going to trace over it in different colors so we can kind of count it together. All right, so my first one is right there, parabola, right? So there's one, okay? Here, I have a horizontal line. There's two. Here, oh, I should use a different color. Let me use a totally different color. I grabbed the wrong thing. Let's do green. Here, we have another like standard line that doesn't horizontal. Isn't that weird? It didn't show all of my green. I have it all green here, and oh, there it finally came. There was quite a delay even between my two screens. That was really weird. All right, so I have 3 on that one. If I'm looking over here at this one, maybe I've got 4 on 8, okay? So I'm kind of seeing 4 different things going there, but let's go with this one. We've got 3. So let's try to write this equation. So f of x equals, I'm going to set up space for 3, and I know one of them is going to be sandwiched in between, okay? So one of my inequalities, whatever the middle equation is, it's going to have 2 numbers on the domain, okay? So it looks like my first breaking point here, it looks like it's at 0. So I'm going to have x less than 0 and then sandwiched between 0 and another number. And I know that this doesn't look, it kind of looks less than, but remember, it's really writing it x greater than if I were to flip that around. So it's okay the way it is. All right, and then I'm looking for my next breaking point, 1, 2, 3, 4. It looks like it's at x equals 4. So I'm going to be less than 4 and greater than 4. And again, you can pick where you want your equal signs to go. I'm going to choose to put them here. Okay. All right, so we are going to try to write, first of all, I need an equation of a parabola for this first one. So I need to figure out the vertex. It looks my vertex is out -1, up 0. So I am plugging into my x minus h squared plus k. So my h is -1. Double negative is going to go positive. Basically, I'm swapping my sign when I go in there with the squared. And then plus 0 isn't going to add anything, so I'm just going to leave it like that. Okay, we're going to do a mini lesson right now on horizontal and vertical lines. Okay, so a horizontal line, oh, that's terrible looking. I think I have some of them as a pencil versus the pen, and the pen looks better. Okay, horizontal line. Oh, that's super thick because I zoomed in way. Is always y equals a number. Okay, that gets you a horizontal line. Okay, a vertical line is x equals a number. And a vertical line slope is undefined. I'm going to erase this stuff in a minute. A horizontal line slope is 0. Okay? And I know you guys can get that, right? I was taught in a meeting with Mr. Lepis today, and apparently he spent the whole period on that with his pre-calc kids. And we know you guys are better than they are, right? So, more advanced even than the pre-calc kids. So, horizontal, y equals, okay? Vertical, x equals, all right? Okay. Who was it? Mrs. Artifer suggested that she remembers that the way that students remember that you've got x equals is vertical is that your x stood you up for a date. Okay, so and that makes it go vertical, standing you up for a date. Okay. All right, I'm going to erase that so I can scribble over there again in a minute. All right, so let's go. We've got a horizontal line, whatever the number is. My number right there is 1, so literally it's just a 1. Okay. And then I've got to write the equation of this line right here. It looks like my slope is pretty confidently up 1 over 1, so it's just x. If you want to write a 1 there so you know you've taken care of it, that's fine. And then so I'm going to count that down until I hit the y-axis, which looking like 1 to -3, so -3. Okay, let's take a look at number 8 together. Okay, actually I'll pause for just a minute there, a couple more seconds just to make sure you've got that. Okay, Let's look at example 8 again this time. So again, I see 4 functions, right? So we've got 1, we've got 2, we've got 3, and we've got 4. Okay, so 4 different functions. So we're going to draw with 4 different branches this time. So f of x equals, I'm going to make it bigger. Okay, so we know we're going to have a domain of x something. We're going to have a squished domain and another squished domain because we've got 2 inside functions and then an x something. So let's go through and just decide our breaking points. Okay, so this first breaking point right here looks like it's at -2. So my first one's less than. Notice it repeats here, right? So that value repeats. My next breaking point looks like it's at 0 and it repeats. My final breaking point in the function there looks like it's at 3, and this would be greater than 3. Okay, and I got to pick some places for the equal signs. I'm going to put it here and here and here, and that should be enough, right? We've got an equal sign on everything. If there was a hole in the graph, we wouldn't put the equal signs. Okay, all right. So let's take a look at writing. Let's see, it looks like I did red first. So the red function, it's a horizontal line. So it would be y equals, or f of x equals, just the number 2. Oops, sorry, -2. All right, let's look at the blue one now. So the blue one, it looks like my y-intercept is 0, so it's technically +0, which I don't really need to write. And it looks like my slope is up 1 over 1, so just 1x or just x. So there are some teachers who are really super picky about notation. There's some notation that I'm picky about, but that's a mathematically correct answer. If you could also just write it as x. But if you write something that's mathematically correct, as long as you've proven your work in here, I have to take that answer. Okay, I'm not going to punish you for not doing it just exactly the way I do it. Okay, that's ridiculous. All right, y-intercept on this one is still +0. Okay, and then looks like we're going down 1 over 1, so we've got a -1x slope, or just -x in that next branch. All right, finally, we have another horizontal line. We just learned that horizontal lines are y equals, and then whatever the number is, it looks like 3. Oh, not 3, -3. Don't let me do it wrong. Sometimes I can purposely do it wrong, then you got to catch me. All right, I'm making the executive decision. I think that's enough notes for today. Okay, we will finish these ones up tomorrow since we've got some time tomorrow, and I didn't want to get much past piecewise this week. So we will work on the sketching tomorrow. And then there's something else. There's a weird, it's an evaluating from a graph. I don't have that officially in your notes, but I'll show you a little bit how to do that tomorrow. So you might not be able to completely do the assignments. You're welcome to try them, and they have some videos there too you can learn from. Okay, but it might be till after tomorrow's lesson to make sure you've got full understanding of what's going on here. Okay. All right, so I'm going to hit the stop button on this guy, and then we need the joke of the day.